Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to find the linear approximation of a function at a given point. So this is problem number 4, section 3.9 in the current calculus text I'm using. And what we're going to do here, what is L of x? L of x stands for the linear approximation at x equals a. In this example, our function is going to be, cube root of x, not cube root of 8. And we're going to try to linearize this function at a point where x equals negative 8. So first I'm going to start this like I start most problems and draw a sketch here of this function. Alright, so got my x-axis. Got my y-axis. And y equals cube root of x, or x to the 1/3 would be the same thing. It has a shape that looks kind of something like this. It is in fact defined on the left hand side because you can take the cube root of a negative number. You can't take the square root of a negative number, but you can take the cube root of the negative number. The point we're looking at here, x equals negative 8, is over here somewhere. I'm just going to put it like maybe right here. The function value here would be negative 2, because negative 2 cubed is 8. That function then, if I were to linearize it, right, I'm going to draw in the linear approximation to that function. I'm going to do this in red. Maybe it looks something like this. Again, it would go through the point negative 2, negative 8. This equation has some form y equals mx plus b. And again, the idea here is that if we look in this region, as long as we don't vary too far to the right or left, the function and the linear function are approximately the same. That's why we can consider that tangent line there a linear approximation to this function at that point. Again, it's only good, though, in the region right around negative 8. So in order to find the equation for the tangent line, we're going to need the slope, which we can get from the derivative. So I'm going to look right over here and say, all right, well, dy dx based on this function differentiates to 1/3 x to the minus 2/3. That's power rule, multiply, subtract 1 from the power, which we could write 1 over 3 cube root of x squared, I guess, if we want something like that. All right, now what I'm going to do is I'm just going to apply that at x equals negative 8. And I think what I'll do here, let's see, so we're going to have dy dx, again, at x equals negative 8. Is going to be 1/3, and I think this thing's going to be a decimal here, so I'm just going to run this through. I'm just going to put negative 8 to the minus 2/3. Give me a moment here, see what I get out of that. Give me just a second. Okay, I get 1/12 out of that. So we're going to have dy dx equals 1/12. Now kind of look at my tangent line here. I can see that my tangent line should have positive slope. This is positive. We like that. I can also visually see, although this is a real rough sketch, but my sketch seems to be indicating to me I'm looking for something slope less than 1. All right, so then I'm going to take the equation for my line, y equals mx plus b, and write that y equals 1/12 x plus b. Now I'm going to go ahead and use the fact that when x is negative 8, y still has to be negative 2, whether you're on the function or the linearization of it. So this is now going to read negative 2 equals 1/12 times negative 8 plus b. So b is going to equal, we're going to have to move this term to the right, 8/12 minus 2. I'll go ahead and just do this in fraction land here. So that's going to be 8/12 minus 24/12 by the time we find a common denominator, which is minus 16/12. And I guess we'll simplify that down a little bit, minus 4/3. So y equals 1/12 x minus 4/3. is a linear approximation to this function at this point. I hope this example helps demonstrate these concepts. I think I'll just make a separate video for my separate examples. Have a great day.